All right. What we're going to do today is a chemical kinetics laboratory. And this is what your document will look like. See it in this camera. See it in this camera. Now there are some things in the method that I'm not going to cover in this lab today because I have a separate video that discusses the theory and some of the calculations that are involved both pre-lab and post-lab. So we're going to focus today just on the actual experiment. So that means we'll skip the first page because it has pre-lab questions on it. There are several pages that I've included in the document that I extracted from the instructor's manual, and they will also go along with that other video. It's in Blackboard, and I'll make sure that it's unmistakable which one is which. Okay, so preparation. What do we need to do to prepare? Well, you need to have already prepared your lab notebook with as described in the syllabus and in Blackboard, and so we're not going to spend a lot of time on that. But as far as preparing for the lab, we need several things. Of course, we need to consider safety first. So I've got my lab coat on, and I'm going to don some gloves because we are going to be using bleach. Technical term is sodium hypochlorite solution. So I got my gloves on, got my lab coat on. And we're also going to need a test tube rack with test tubes in it. It's supposed to have 3. I've got more than 3 just in case I need an extra one. We need the blue dye. We're only going to use the blue dye in the method. So in the method you'll notice that I've crossed out any reference to the red dye. We're only going to do the blue dye. If we had a full lab going on and 2 or more groups, then one group could do one color and one group could do the other. But since it's all me by my lonesome, we're going to do the blue dye. And the method calls for diluting 1 drop of concentrated blue, number 1 food coloring, which is actually what it is, in 50 milliliters of water. So I've made up excess, and this is the already diluted blue dye. That's ready to go. We're also going to need sodium hypochlorite solution. Right here. It's 6% weight, or mass. And I discussed that in the other video, what to do with that value. And when you work the pre-lab questions, you need to watch that other video that will help you with answering those questions. So that's the sodium hypochlorite. Then we also need a sodium chloride solution. This is our diluent. In other words, when we run the first kinetic experiment, we're using full strength bleach. When we run the second one, we're going to cut that concentration in half. But we need to make up the difference with some type of diluent that does not in itself influence the kinetics of the reaction. So we use an equal concentration of sodium chloride. And the other video also discusses why we do that. Okay, we're also going to need 2 pipettes. I've got more than 2 here, of 5 milliliter volume. These are volumetric pipettes, which means that when we fill the pipette up to the mark and then dispense it, it all drains out, and anything left in the tip after we drain it out is accounted for in the calibration of the pipette. So everything doesn't have to come out. We also need 10 milliliter graduated cylinder. Okay? And of course we need our pipette bulb, because we're not going to mouth pipette these things. We're going to use a pipette bulb. And those of you who have had the CHEM104 class with me, well, I have to qualify that because CHEM104 last semester was also virtual. So that's a problem. But watch closely and you'll see how I use a volumetric pipette. What else? We'll need cuvettes. This is a cuvette. I'll show it to my headgear. Let's see. Yeah, show it to my headgear here. Cuvette. That's a cuvette. And this cuvette goes in the spectrophotometer, right here. And this is where our solution goes. As we add the blue dye, we add the bleach to it, and then we start taking measurements. And the measurements we take are of absorbance. And this document and the other video discuss absorbance, why we use absorbance as a substitute for concentration, because we can't very well measure the concentration of the blue dye easily. So we measure it indirectly as a measure of absorbance. So it absorbs a certain amount of light, and as it decolors with the bleach, the absorbance should go down over time. All right. I think that's everything we need. I've already warmed up the calorimeter, the spectrophotometer, and set the correct wavelength for the measurement, which is 630 nanometers, and that is also contained in your document. So it's ready to go. We'll reset it to 0 in a few minutes once we get ready to use it. But first, what we have to do is in the method, part 1, we have to determine what's the correct concentration of bleach relative to the amount of blue dye that we use, so that it gives us a nice even decrease in blue color over time. We don't want to put so much bleach in there that the color goes like this and just crashes. We can't very well measure that very easily. And we don't want to put so little bleach in there that it just takes forever for it to decolor. We need something that's reasonable. And that's why the method calls for this first step with the test tubes, where we add some blue dye to, we add water to one of them as our reference. We add blue dye to the first and the second tubes. And so the first tube will have water in it. The last tube will have blue dye in it, and we're not going to do anything with that. There's a 0 color reference is the water, and a full color reference is in the third tube. And in this middle tube, we're going to conduct our preliminary experiment so that we can determine what is a good ratio of bleach to blue dye. I already know what it should be, so I'm probably going to take a few shortcuts in the interest of time. The method says that you start off with 5 milliliters of the diluted blue dye, and then you add 2 drops of bleach to it and start your timer. And when it appears to have completely discolored, then you note the time, and if the time is within, let's see, I think they're shooting for 3 minutes. Yeah, 3 minutes. You want the solution to be colorless in just under 3 minutes. But I already know that 2 drops of bleach is not going to do much. So what I'm going to do is shorten the process. And we're going to start with, let's see, how many? 5 milliliters of the dye. That's what the volumetric pipette is for. And then, I'm missing one thing. Little dropping pipettes. 1 second. Here we go. These are known as transfer pipettes, which just means you pick something up and you put it over there. It's important, though, that when we determine how many drops that we're going to put in there of the bleach, that we use only this pipette, because they're not calibrated. I mean, we pick up one pipette and it gives you a certain size drop. Use a different one, it'll give you a different size drop. So we need to use the same transfer pipette in the whole procedure. All right, so I'm going to take this bag and put it out of temptation's way. Okay. So that's our and we need Chem wipes. These are Chem wipes, right? Lint-free, so we can dry things. And the other thing is, when you use a cuvette like this, it's got a mark on it to show you which way is which. And we want this little mark to be facing out. And we look at the spectrophotometer and see which way is the light beam traveling, because we want to know where is it going through this cuvette. So I'm going to look at the machine just to verify. And we can tell that there is a hole on one side and a hole on the other side, so that the light beam goes from crossways like this. So that means this side and this side need to be perfectly clean. No fingerprints. That's another reason that we're wearing gloves, because fingerprints will change the absorbance. Okay, so we've got a clean one there. Let's clean another one, just in case we need it. All right. Okay. So I'm going to set that aside for now. All right. So, first thing we need to do is activity 1. How many drops of sodium hypochlorite does it take to decolor the blue dye in less than 3 minutes? All right. So we need 5 milliliters of, 5 milliliters of water. Let's see here. Actually, we don't need to be exact with water or with the full strength blue dye, because we're not going to add anything to it. We just need to be very accurate with the middle one, the one that we're going to add bleach. Okay. So here's how you use a volumetric pipette. We just push on the pipette bulb, and there are 3 positions on it. The top one is A for, what is A for? Aspirate. So you press on that, it opens the valve, and you squeeze the bulb. And that primes it. See? Now, if you want to pick up some solution, there's an S key on here, which is, I assume, for suck. And you just have to be careful, because it'll come up pretty fast. So we put it in the solution, and we withdraw some of the solution up into the pipette, past the mark. There's a mark on here, the calibration mark. Now we need a Chem wipe, and we wipe the tip. We don't want anything on the outside. And then, if you're careful, you have to have it eye level with the mark. And there's another mark on here called E, which is expel. So I hold it steady, and I press on expel, and I watch the meniscus, the concave curve in the top of the liquid, until the bottom of the meniscus hits that line. There we go. Now, anything collecting on the tip, we just touch it to the glass, and that's it. It's ready to go. Now, I'm going to take the middle tube, and all you have to do is hit expel, and it drains out. You can see that maybe with my headgear. Maybe you can see it on the camera as it increases. There we go. When I post this video, it's going to be split screen with headgear in one side and the full view in the other. And once it starts dripping, you just touch the inside like that to get that last drop off. Anything left in the tube is not part of the 5 mils. Okay? All right. So we're going to set that over here because that's the one we used for the blue dye. We may want to use it again. Set that tube there. Oh, the full strength blue dye. All we need for the full strength is about 5 milliliters because we're not going to be adding things to it. We're just doing a color comparison. So I'm just going to measure out 5 mils like that, roughly. And it's not going to change through this part of the experiment. There you go. That's full strength. And water for the half strength. Let's see, how high should it be? About there. And we just fill it up to that mark. So there we go. So let me get down with my headgear and show you what it looks like. I hope my headgear, it looks like the water's a little high, but that's okay. All right. Okay. Now we're going to need a timer. You can use anything. I'm going to use my cell phone. It's got a stopwatch in it. And I need to shut my phone up. I think that should do it. That'll keep it quiet. Now I need my stopwatch. So let's see if I remember where I put it. I think I put it under travel. There it is. And here, let's see, my headgear can see it. Okay, I don't want alarm. I want stopwatch. There we go. So we're just going to start that running and see if it's decolored after 3 minutes, right? So how many seconds is 3 minutes? Well, this is in minutes and seconds, so we can go 3 minutes and 0 seconds. All right. So what are we going to do first? Well, I know 2 drops is not enough. And I know it's a lot, but I want to give you the experience. So I'm going to start at 10 drops. Okay? So let's open the bleach. Put it back in its secondary containment, right? Hazardous materials, usually you store them in some sort of secondary containment in case the primary breaks. That's standard practice. Okay, so here's the one we're going to test. And we're going to put, using this pipette and only this one, we're going to put 10 drops in. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and start the timer. And mix it. This is one way to mix it. You just hold it steady with your top hand and tap it with the bottom, and that mixes it. It's called vortexing. There you go. And we can look at side by side. Don't see anything happening yet. I'm gonna put these other test tubes right side up because they tend to slide out of the little holes if it's flat bottom down. There we go. So we're coming up on 45 seconds. All right. There's a minute. And do I see anything? One way to tell the difference is you need something light behind it. If the color is dark, you want something light in the background. If we were developing color, we must start off with a black background. We're going to put a light background. It's easier to see that way. And it's somewhat discolor. Hopefully this won't take too long before they kick me out of the building. And for safety, let's cap off. There we go. So, minute and 45. I don't think it's going to make it. Not with 10 drops. So what I usually tell my students when we're live, face-to-face in the lab, is the best way to do something like this, to find out where the what we would call the focus of the experiment, the focus of the concentration is on a particular value. I talk about in the olden days when we used to have cameras that required you to focus the lens. Now, of course, they autofocus. But back in the old days, to focus a lens, you'd learn how to bracket. So you're looking through the viewfinder and out through the lens. It's a single lens reflex camera. And you can focus through the lens. So you go out of focus, and then you go one way, in focus, and out of focus on the other side. And then you come back to focus, and then you go just a little bit past, and then you gradually bring it closer, closer, closer until you get it right on focus. So that's what we would do here. 3 minutes coming up, and we have some but not significant decoloration. Okay, so we're going to stop the stopwatch, and let me finish my description. And what I would tell them to do is, if 10 milliliters is, 10 drops is not enough, and not nearly enough, then why don't you just go really high on the next one, like 40 or 50 drops. And if that decolors too fast, then you come back in between somewhere. That's what I would normally do. But I know what I'm heading for, so I'm just going to do the next one. We have to clean this one out. We can't use that tube again. We can leave the other two, the 0 and the 100% color, in place, because they're just a comparison. But we're going to take this one, and it's non-toxic, so I'm going to flush it down the drain with plenty of water. Distilled water, that is. Okay. When you shake water out like that, be sure and have a good grip, or you're going to have glass on the floor. There we go. So I now need 5 more milliliters of the blue dye. Okay, same thing as before. Here we go. Fill up our pipette. Okay. Wipe off the tip. You don't want any clingers on there. And then bring it back down to the mark. Let's see, expel. Here we go. I'm not sure if the camera's picking this one up on my head. Now we're going to put this in here. And I'm going to double the number of drops. We had 10, then I'm going to put 20. Notice I'm not recording anything, because this is just semi-quantitative. We're finding out how many drops of bleach it would take to put us in the ballpark. We're going to quantify it later. Okay, There we go. So this time I'm going to put 20 drops in. Let me reset my watch. I'm going to stopwatch. There we go. And one, 2, 3, 4, 10, 11, 12, 13, 14, 15, 16, 17, 19, and 20. Start the timer. And mix it. Vortex it. We have a machine that'll do that. Well, not here. I used to use one. You just hold it and stick it in the machine and it would spin like crazy. Okay. So while that's going, I want to show you something else. So I'm going to go off of this camera and rely on my headgear to show you what's next. Now I've prepared a table here, and this is the one I'm going to use to fill out the information as the experiment proceeds. Then I'm going to take this table and put the information on the board right here so that I can photograph it and have a permanent record of it. Well, both are permanent records, but I like to have it in large view for my class. So it's just force of habit, really. I really don't need the board, but I'm going to do it anyway. Let's see. Doing all this talking makes for a dry throat. Okay. So I'm back on station. Set that over there. And a minute and a half. And we'll take a look at it. It's working a little better. It's about where it was at 3 minutes. Right now, at a minute and a half, it's about where the color was at 3 minutes before. Okay. Let's see, I got another minute. While we're waiting, I'm going to pull this headgear off and take a look at my battery. I'm paranoid. Battery's about half gone. All right. I don't want the battery to run out or it'll stop recording. So, at some point, I'm going to pause the video and change my battery. 2.5 minutes. All right. It's getting there. Okay, I can safely say that after 3 minutes, this is not going to be decolored enough. So I think in the interest of time, I'm going to go ahead and stop it now. So I know it's not going to make. And then I'm going to use 30 drops for the next one. Okay, we just need to clear this one out. And you can see, let's see, you can see the color's not quite what it should be. Okay, so we need 5 more mils of the blue dye. And a chem wipe. And now we're going to bring it down to the mark. Oops, I went too far. So we've got to go back up. Wipe it off again. Pay closer attention. There we go. There. Put this in the tube. There it is. 5 milliliters. Now I'll tell you right now, that when we use these cuvettes, these square things that we put in the spectrophotometer, they don't hold 5 milliliters. Right? So that means we're going to have to establish the ratio of so many drops of bleach to 5 milliliters of volume. Then we've got to find out how much volume those cuvettes will hold and prorate the amount of bleach to match the volume of the cuvette. That'll come in just a few minutes. Now I'm going to put 30 in here. 30 drops of 6% sodium hypochlorite, and then we'll start the timer again. Okay, so I'll do it quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 6, 7, 8, 9, 10. That's 30. Okay. Start the timer and hold it firmly and vortex it. There we go. Now we can let that sit for a minute. So while we're doing that, why don't we find out how much volume one of these cuvettes holds. I got one that I didn't clean, so I can use this one and just set it aside. So if we happen to put 10 or 20 drops, or 30 or 40 drops of bleach, well, it's going to be less than that, of course, because this doesn't hold 5 mils. But we need to leave a little bit of room in here for the bleach and for mixing, some headspace. So we probably just want to find out where does the light beam pass, and then judge the amount of volume we want to add to this. Then we can prorate it. So let me just stick this in the machine or beside it and say, where does the hole fall? The hole falls right about there. I don't know if you can see that. Right about there. So if we fill it up to maybe twice that much, then that would be a good measurement. Okay. And we only have to ballpark it. Actually, we need a way to measure the volume accurately. So it depends on the volumetric pipettes that I possess. So I've got a 3 milliliter here. Let me see if I can find a 2 milliliter. I'm going to use my head camera here. Right, here's a 2 milliliter. So let's just do 3 milliliters of water and see where it comes. How are we doing on time? 2 minutes? It's getting there. That was 30 drops. Let's do a check. It's not completely gone yet. 30 drops. Hadn't reached 3 minutes yet, so we'll check it at 3 minutes. But in the meantime, let's do 3 milliliters of water in a cuvette and just see how far it goes. There we go. All right, expel down to the mark. 3 milliliters. Let's put this in the cuvette. Oh, that's perfect. 3 milliliters. So when we get ready to load the cuvette, we're going to prorate it at however many drops the bleach we put in there. The ratio of 3 to 5 would be the same ratio as X to the total number of drops of bleach. Okay? Maybe I'll put that on the board when we do the calculation. All right. So that's past 3 minutes. Let's see what happened. I think we got a winner. Maybe hard to see on camera. Here, take these out. There we go, and up against me. There we go, that light background. Maybe you can see that the middle one is virtually colorless. There's always going to be a little bit of color left relative to pure water. So I think 30 drops in 5 milliliters of dye is the ratio. Okay, so if that's the ratio, and we're going to use 3 milliliters in our cuvette, let's go over to the board, and I'll just show you. I mean, you probably already know, but I'll do it anyway. So here's what it looks like. A ratio of, 30 drops to 5 milliliters is the same as so many drops to 3 milliliters, right? So how do you find X? Well, you divide 5 into 30, which is 6, and 3 times 6 is 18. So we need 18 drops of bleach, and that is full strength, right here, full strength sodium hypochlorite. So let's write that value in here. 30 drops for 5 mils, and let's underneath, let's say 18 drops per 3 mil of dye. Okay, so what would half strength be? Well, half strength would be 15 drops per 5 mils, or half of this one, 9 drops in 3 mils. Okay, so with this one, we're going to put 18 drops in the blue dye for the full strength. But when we get to this one, we're only going to use 9 drops. Well, the concentration won't be the same unless we make up the other 9 drops with some, we call it a diluent, some diluent that mimics the ionic strength of sodium hypochlorite, but does not decolor the dye. And that's why we use sodium chloride instead of sodium hypochlorite. So 9 drops of dye, but we also use 9 drops of plus, let's see, 9 drops of sodium chloride solution. Now, I didn't tell you what concentration that was, did I? 0.875, I believe. 0.875 molar. Okay, so now we can actually do the kinetics experiment. Okay. And we're going to make a measurement every 10 seconds. And that doesn't mean we set the watch, stopwatch, run 10 seconds and stop it, take a measurement, and then run it 10 more. Because in the intervening time of taking the measurement, you've advanced some more time, and the reaction's not stopping. So you let the timer run, and you take a measurement every 10 seconds on the timer. That's a common error that my students make. Some of my students, I should say. All right. I made a mistake. Sodium chloride is not 875, it's 878. Let me make that correction. I think I can do it without erasing. Turn the 5 into an 8. There we go. Now we're ready to run the experiment. So, what are the particulars of operating a spectrophotometer in such a way that we can time the experiment? Because as soon as that bleach hits that blue dye, it starts to decolor, right? So, we want to have the machine set up and ready to go. And then we're going to add the blue dye. And then into the cuvette, then we're going to add 18 drops of sodium hypochlorite and immediately put it in the machine. Start taking readings. Okay? So I'm going to put that over there. And let's see, I put my stopwatch on this side. Okay, so how do you set up a spectrophotometer? Well, you have to start from 0. But there's 0 and then there's 0. Right? So what would 0 be? Well, when all else fails, you use some type of blanking material. Water is okay, because water has an absorbance. It may be small, but at this wavelength, it could be significant. So we could use this cuvette full of water, or, no, that's the best place to start. Yeah, let's use water. So, these cuvettes are supposed to be calibrated in such a way that they have similar absorbances empty. I got something here. I don't think it's in the light path, but it's annoying. Let me get a different cuvette. Yeah, that's better. Right. Now, since we're only going to use water in this blank, it doesn't matter how much it is, as long as it's water in the light path. All right. So what I want to do is check the absorbances of these 3 cuvettes to see if they're identical. If they're not identical, then we've either got to make a correction or we've got to use only one cuvette for the whole thing. So let's just take a short check. Take these 3 cuvettes, and there's a key on here that says 000. We hit that. Should be zeroed any second. Must still be thinking. There we go. Now it's 0. Now let's put this one in. Okay. 0.16. So the cuvette itself does have an absorbance. So let's see what this one does. 0.16. That's good news. And this one, 0.16. So we can use all 3 cuvettes interchangeably. They each produce the same baseline absorbance. All right. So that means we can use one to blank. So we'll take this one, which I've cleaned, and we'll put water in it, like that. And we'll use this to set the machine to 0 with an aqueous medium in it. Okay, now we're going to set it to 0. It's thinking, averaging signals. Okay. There we go. I'm just going to leave that there until I need to do something. So now what I'm going to do, we need 18 drops full strength, and I need to get my pen out. We record data with pen, not pencil. And let's see, the date is January 19th, 2021. Okay. So now, I'm going to pause for a second and check my battery. Yeah. It's still recording, but I don't like the condition of the battery, so I'm going to stop it. All right. Okay, here's the problem. This is the first time you see me on this screen because I forgot to start the recording on that screen. But I do have the headgear recording. So the first part of this video is going to be purely headgear, and when you hear me talking on the headgear to the other camera, the other camera's not recording, but it is now. So we're at the point now where we're going to actually conduct the kinetics experiment for full strength bleach. And we need 3 milliliters, right? 3 milliliters of blue dye in the cuvette. So we've got to take it up. And I'm going to, since we had water in this before, I'm going to use this first one to rinse it out. And I'm just going to drop it in this other test tube. So now, if we had any water droplets left in there, they've been diluted out and rinsed out. And the next time we pick up blue dye, it will be pure. Okay, so let's try that again. There we go. Past the mark. Now, expel down to the mark. There we go. Put this in the cuvette. And I hold it front to back because side to side is where the fingerprints go. Where we don't want them to go, of course. 3 milliliters. There we go. Now, set that aside and put the lid back on the blue dye. I need 3 or 4 hands here, don't I? Okay. Let's be sure the blue dye is down in the bottom. Now, okay. So I need to add the 18 drops of bleach very quickly and get it in the machine. Okay, how are we going to mix it? Well, it's not going to be easy, right? So what I could do is get another pipette and mix it by sucking up and blowing out a couple of times. I think I'll do that. So we'll set that there and get it ready. It's on 0. Now I need to pull this 0 cuvette out and get ready to put the one with the bleach in it. Okay, ready? This is going to happen really quick if I do it right. Okay, ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And okay, let's put it in there. Start the timer, and the first reading is 0.14. Oh, it's the wrong wavelength. Shoot. We got to start over. It's a mistake. We have to start over. I got the wrong wavelength in. So there's a way to reset the wavelength, and I'll do that right now. There. Now we have to reset the zero. And we've got to start all over again with the cuvette. So let's clean out the cuvette. Now, since this other cuvette is matching to that one, I'm going to let that one dry and use this other cuvette. Okay, but I have to check the zero, and it's zero again. Okay, we're good. We're good zero. So I've got to go back and start over again. I'm not going to narrate this one because I'm doing exactly the same thing I did before. Okay. Now I'll bring it down to the mark. There we go. And let's put it in here. And the cuvette is just about there. All right. Okay. So now we've got our cuvette primed, and we just need to add the bleach. Okay. Ready to go. Let's reset this, and we'll do the timer. Okay. 18 drops. 18 drops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right. Put it in the machine. Start the timer. First reading, 0.41. .35. 20 seconds. 0.32. 30 seconds. 0.29. 40 seconds. Coming up on 40 to 6. Okay. 50 seconds. 0.23. 60 seconds. 0.21. 70 seconds. 0.19. 80 seconds. 0.17. 0.15 for 90 seconds. And 0.14. You may be wondering when to stop. The method says once you get below 0.1, you can stop. 0.12. Coming up on 120 seconds, 0.11. The next one will probably do it. Yep. We're at 0.10. So that experiment is done for data collecting. All right, so we take this one out, like that. Okay. Now the next one, let's see. We could use a Chem wipe and pick up those little beads of water that we use to rinse it. That's not too difficult. There we go. Now, in this one, we need the same amount of dye, 3 milliliters. So we'll just go in and repeat that step. Oops. Wipe off the tip. Don't want any big globs hanging on there. And down to the mark. And remember, the mark has to be eye level. There we go. There. Okay. So that's dispensed, 3 milliliters of blue dye. Now, what do we put next? The bleach? No, the answer is no. The next thing we put in there is sodium chloride, because it will not discolorize. But we have to use the same dropper, so how do we do the dropper so we don't contaminate it? Well, you wipe the outside, of course, and probably the best case is to put some water somewhere, like this water from the cuvette, and rinse the inside of the pipette. Just fill it up with water. There. There we go. So now, we need a total of 18 drops, but half of them should be sodium chloride. So we'll do 9 drops of sodium chloride in here first, before we add the bleach. Sodium chloride, 9 drops. We can take our time with this one. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now, I'm not going to recontaminate that, possibly. So we just spit that out into the sink. It's nothing but salt water. And now I want to get that diluent out, so I'm going to do the same thing as before, only this time I'm going to rinse it out with bleach. And wash it down the drain. Here we go. Now we're ready to add the bleach. So I got my timer set to 0. Let me check the 0 again on our machine. Sometimes these machines will drift over time. So let's put some water back in here and check the 0 point. Okay. It's still good, setting on 0. Very stable machine. Okay. So now we do the same as before, only this reaction will not proceed as fast because we have a lesser concentration of bleach. Here we go. I see some contamination on the outside. Probably came from transfer of liquid, so let's just be sure it's clean. There we go. Now we're going to put 9 drops of bleach and off to the races. But before I do that, if I want to use this one again, it's had full strength in it, so I'm going to use a separate one to do the mixing. Okay. Set that one there. 9 drops of bleach. Here we go. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, mix. Mix. Put it in the machine. Start the timer. 0.47. Ten seconds. 4-4. 20 seconds. 4-2. 30 seconds. 4-0. Next one. 3-8. Next one, coming up on 3-6. Next one, every 10 seconds. 3-4. Another 10 seconds. 3-2. Another 10 seconds. 3-1. Next one. 2-9. Next one. 2-8. Next one. 2-6. Next one. 2-5. Every 10 seconds. 2-4. Next one. 2-2. Next one. 2-1. Next one. 2-0. Next one. 1-9. And 1-8. 0.17. 0.16. 0.16 again. 0.15. .14. We're still going. At 4 minutes, 0.13. And 0.13 again. We might be bottomed out. Nope. There's 0.12. Next one, 0.11. And 0.10. There we go. Okay, so that experiment's done. We don't need a stopwatch anymore, so we'll put that away. Okay, what I mentioned earlier that I thought was being recorded but wasn't, was that the theory and the calculations that are going to be required for this experiment are contained in a separate video. So you'll need to watch both of them. Get your data from this one, or you can watch them in any order you want. Of course, you can't open up this video, until you've submitted your pages from your lab notebook, and I've given you a grade of 80% or better, which means you're actually ready to do the experiment. Okay, we got one other thing that has to be done. And let's see. Do I have a place for it? I don't have a place for it up there. Okay. What we need to know, the density of the bleach, here it is. It's in your document under Activity 1, which we skipped, but we're going to come back to it now. Under Activity 1, the density of the bleach is 1.09 grams per milliliter. You're going to need that in your calculations. The other thing you need is to know what is the mass of each drop of bleach that you added. If we know the mass of the drop that's added, and we know its density, then we know how many milliliters of the bleach was added. And we use that in the calculation of the final concentration in the cuvette, in the reaction vessel. So to do that, you just pick a number, 20, 30, 40 drops, and find out what the mass of that many drops is. Then when you divide by that many drops, you get the mass of each drop. Okay? So that's what we're going to do next. We're going to use the analytical balance, and we're going to get the mass of, say, 30 drops. 30 should be a nice round number. So that's what I'm going to do next. Turn on the balance. Be sure it's leveled, and it's not. Somebody's been messing with it. There we go. Now it's level, and we can turn it on. Let's see. There was an on switch. Oh, it's not plugged in. That would help. There we go. Now it's turned on. the data over there. And while we're waiting for the balance to stabilize, we're going to take the bleach with the same pipette that we used for the experiment. Right? Otherwise, the mass of 30 drops would be meaningless if we didn't use the same pipette. So there we go. And we need something to weigh into, something that we're not going to weigh directly onto the pan. So we'll get us a little plastic weigh boat that we can use once and throw away. Here we go. That'll hold 30 drops easy. The balance is 0, set 0. So now we're going to put our weigh boat in there, let it stabilize, and then 0 it. Check it to see if it drifts. Onto that zeroed, we call it tared weigh boat, and whatever weight we get is the weight of the drops. So we need 30 drops. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. Now let's close the door and let it stabilize. .0866. 1.0866 grams per 30 drops. All right? So just divide 30 into that and you find out how many grams for each drop. And I'm going to, just as a reminder, I'm going to write the density here, 1.09 grams per mil. And then we use grams per mil, the density, to convert grams into milliliters. All right, so that's all the information that we need, I believe. And I'm going to put it on the board and take a photo of it. And let's see, in the process of doing that, I need to, this is part of the cleanup. There's the setup, there's the experiment, and there's the cleanup. There we go. All right, so we can turn the spectrophotometer off. We're finished with it. There's a power button in the back here somewhere. There we go. And we can remove this weigh boat. And we can unplug it. And then we can dispose of the bleach with plenty of water. Okay, and that'll be disposed of. That's throw away. Throw away, throw away. We'll clean out the cuvettes. We'll do that later. I'm not going to bore you with that part, but I do want to put the data on the board. So I'm going to go off of this camera and rely on my headgear to finish up. Okay, so this is full strength, 30 drops. Let's put this information up here. The bleach, 6% sodium hypochlorite at 1.09 grams per mil. We used so many drops, and this will give you the mass of each drop, 1.0866 per 30 drops. There we go. Now I know why I'm putting this on the board, because my handwriting on this paper is pretty bad. So we're going to get the absorbance. And you'll find out what absorbance means when you watch the other video. Okay, so 0.41, and notice if there's a decimal, it's a fractional decimal fraction, and there are no whole numbers out here, you always put a 0. If you do it like that, that's called an orphaned decimal, and it's bad. If you learned it in school, in high school, grade school, whatever, unlearn it. Always put a 0 before the decimal. 0.32, 0.29. Let's make that a little more legible. 9. There we go. 40, 0.26. 0.23. 60, 0.21. 0.19. 0.17, and then we'll go over to 90. Let's get rid of this so we won't confuse the matter. 0.15, 0.14, 0.12, 0.11, and 0.10. Full strength. Half strength. Okay, we're going to need some more positions down there, so I think what I'm going to do is I'm going to scrunch these together. Let me rewrite this one. Get this one down to about 150. So this one's 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140 will do. And over here, we're going to rewrite these. Okay, we need to get down to 280. That's good. This is 140. 280 will be twice, so it'll be spaced properly. 150. 150. 160. 170. 190. 200. 210. And notice these are in seconds, right? Need to use the same unit of measure for both sides, all the way down. No minutes, seconds only. 210, 220, 230, 240, 250, 260, 270, and 280. Now we can put in the absorbances. 0.47. Notice the starting point for this one is higher than this one. When you put in full strength bleach, part of the reaction has already occurred. So our 0 point, some of the blue color has already disappeared. 0.44, 0.42, 0.40, 0.38 for 40, 50, 0.36, 0.34 for 60 seconds, 0.32, 0.31, 90 seconds, 0.29, 100, 0.28, and 110, 0.26, 0.25, 0.24, and 140, 0.22, and 150, 0.21, 0.20, 0.19, 0.18, 0.17, 0.16, 210, oh, we got a 16 again. Start to slow down. 220, 0.15, 230, 0.14, 240, 0.13, 250, 0.13, 260, 0.12, 0.11, and 0.10. Okay, there's all the data in one place. And let me back up and maybe come out. Hopefully get a picture of the whole thing in my camera. I'm gonna take my cell phone and do a still for this one also. Okay, that's it. That's all you're going to need to finish this experiment. And this experiment requires a formal report. All right. Okay, so that's it. Data's on the board. I'm going to take a picture, and this experiment is finished. All I have to do is clean up now. You don't have to watch me do that.